Testing. 1, 2. Oh, there it goes. Oop. Alright, this is section 6.3. It's basically the word problems that go with what you've been doing in the last two sections. So what we're looking at is taking a distribution and turning it into a normal distribution where the mean is 0 and the standard deviation 1. And so we're going to put it on this kind of a scale and get our new distribution. We're going to use our tables to go and look up our values that we need to find the area under the curve, because we know the area under the curve is the probability. Okay, that was all from sections 1 and 2. Alright, so we're just going to toss some words at it and do just a couple of these real quick, and that's it for 6.3. It's very short. So, first problem. Recently, birth weights of Norwegians were reported to have a mean of 3,668 grams and a standard deviation of 511 grams. Why Norwegians? I don't know, because it's fun. We're going to choose a Norwegian baby at random. Find the probability the baby's birth weight was less than 4,000 grams. Alright, we're going to go grab a baby. This is the mean. Mean is mu. Standard deviation. This is the value that we're looking for, so it is x. What we're going to do is find out how far away from the standard deviation that is. So we're going to use our handy dandy formula for z. X minus mu over sigma. Okay? So let's go find his z-score. I'm going to take 4,000 minus 3668 divided by 511. Let's go find out what we get. Now z-scores on your table are in 2 decimal places, so we always round z-scores to 2 decimal places. Alright, so we get 0.6497, so I'm going to go 0.65. Here's what's happening. We changed it from having a mean of 3668, standard deviation of 511, whatever that is, and we want to find, here's 4,000, the probability that when we grab that Norwegian baby, his weight is less than 4,000. Okay, so we standardize it. Here's the center. This is now at 0.65 standard deviations above the mean. Neato. So, we go to 0.65. There it is. And this is going to be the area to the left. Good news, that's the area we want. So going to 0.65, I find that the area is 0.7422, which means a 74.22% chance. Okay? Yay. Since it was to the left, I didn't have to do any extra work. Let's change it up a little bit. All right. Here's our Norwegians. We're going to grab a baby at random. You probably shouldn't grab Norwegian babies at random, I'm just saying. We're going to find the probability that the birth weight is between 3,000 grams and 4,000 grams. Remember what that looks like? Here's our mean, 3668, 4,000 and 3,000 is in between. All right, so we're going to normalize it, and this will now be 0. Remember how we found 4,000 was 0.65 was its standard deviation? Let's go find 3,000. We'll see. Calculator. All right, go find the z-score for 3,000. Hit pause and go do it yourself. Two decimal places. Since it's 307, I'm going to go 1.31. Okay, negative 1.31. All right, so we've changed from the old numbers into the new z-scores so that we're using a standardized amount. Remember when we looked at 4,000, it said that the area this way was I forgot what it was, hang on. 0.657422. Now let's go look up negative 1.31. Other side. Negative 1.31. So from here to the left is 0.0951. Do you remember what we do with these two amounts? I need the amount in between, so we subtract 7422 minus 0.0951. 0.6471, or about a 64.71% chance. Yay. All right, let's come back to America. I know you wanted to. Women's heights are normally distributed with a mean of 63.6 inches and a standard deviation of 2.5. I want you to pause and try this one on your own. You're going to find that the heights of the Rockette dancers are they must be between 65.5 and 68 inches. And so I want you to find the probability that a random woman is going to meet this height requirement. Okay? We like random people in this probability. All right, hit pause and go do it yourself. All right, so first we're going to change 65.5 to a z-score. X minus mu over sigma. But we're also going to need a z-score for 68. So I'm going to write those both down so I can go calculate them both at once. Okay? Remember that we need them to be between those two. Between, this should have been higher up, 65.5 and 68. Okay? All right, here we go. I got 0.76. And 1.76. Okay, so I'm going to go look up those z-scores. This is at 0.76. This one was at 1.76. Okay, side. Now, I know Joseph's out there screaming at the camera, Miss Noble, there's a way to do this on your calculator. It's so easy. I understand. That is not the way I want to do it, because it does not help us to understand what's happening. There will be some calculator stuff later. I promise we won't do everything by hand. But this thing here, I want to do it by hand for now. Alright, here's my two numbers that I came up with from the table. We are finding between, so we are going to subtract. Alright, point. Uh-oh. Typo. Here we go. 1844. So, you're walking down the street, you grab a woman. There's an 18.44% chance that she is going to fall into the height required to be a rocket. Huh, so easy to be a rocket. What do you know? Just kidding. Alright, I'm going to add 6-4 to this day also, and then I'll put out a Google Doc that will have both of them on it.